Hello, my name is Katie Blix. I'm in 8th grade and I'm from River Springs Middle School. The name of my project is Shining a Light on Sunscreen. It is in the category Biomedical Health and Sciences. The reason why I'm doing this is because I have used sunscreen my whole life and have doubted its the need for it, and if it actually helps. So I wanted to do this to prove to myself it does. The purpose of this experiment is to find out whether sunscreen does anything to protect from the sun, and if SPF matters. I will test this by using no sunscreen, SPF 30 sunscreen, and SPF 50 sunscreen on sunprint paper. Sunprint paper is a type of paper that when blocked from the sun, it turns a lighter color. I will use this because I cannot test it on myself, and it's the closest thing I can use. The independent variable is the amount of sun protection. The dependent variable is the value of the color of the sunprint paper after I leave it in the sun. The value is a number that shows how light or dark a color is. 0 is black and 1 is white. The control group is the no sunscreen group. If it wasn't clear from my actual title, my question that I'm trying to answer is, does sunscreen and SPF protect from the sun? This is my research based on how sunscreen helps protect you. So the sun damages the skin by burning melanin, which protects the skin from the sun's ultraviolet rays. Too much exposure can lead to reduced elasticity and aging prematurely. Sunscreen protects skin by blocking and absorbing UV rays with a mix of physical and chemical particles. SPF stands for Sun Protection Factor. It tells how long the UV rays will take to redden your skin. A higher SPF also means more chemicals added to the product, and these are my sources that I have. This is my hypothesis. If I put sunprint paper with no sunscreen, SPF 30 sunscreen, and SPF 50 sunscreen out in the sun, when the sunprint paper with the SPF 50 sunscreen on it, then the sunprint paper with the SPF 50 sunscreen on it will be the lightest in color because SPF 50 sunscreen has more chemicals like zinc oxide, which allows less UV rays to reach your skin. My overall goal is to find if sunscreen really does protect from the sun. Here are my materials. Now my procedure. What I did was cut the sunprint paper into 30 equal size squares and put them into 3 groups of 10. The 10 squares I labeled none, then 10 the second group of 10, I put the trial number, and then, I put them into 10 groups, and then I labeled them none, and then the trial number, SPF 30, then the trial number, and then SPF 50 and the trial number. I then put them into groups of 10 on a large piece of cardboard, and then I put plastic bags over the squares. I did this so I did not have to put the sunscreen directly onto the squares, which I would not be able to see the squares when I was done. I put the plastic bag on the squares with no sunscreen as well to control and make sure that was not a variable. I put an even amount of sunscreen on the SPF 30 group and then the SPF 50 group of the 2 sunscreens, and then left them out in the sun for 5 minutes. Then I followed the instructions of the sunprint paper to get it ready. After I had done that, I scanned each square, and then I put the picture of that scanned square into the website that is on screen of number 18. After I did that, the website told me the hex code. The hex code is a specific code for each color. Then I put the hex code into another website on number 20, which told me the value of the square, or the picture of the square. The value, again, is how light or dark a color is. 0 being black, and 1 being white. Of course, after I got all the data, I put it into tables. Here are the pictures of a picture of each group, one of the squares. The first picture on the left is of no sunscreen. The middle is SPF 30 sunscreen, one of those squares, and then the right is SPF 50 sunscreen. You can visibly tell the color difference between the no sunscreen group and the two sunscreen groups. Additionally, the SPF 50 sunscreen is slightly lighter than the SPF 30 sunscreen. That means that less sun, UV rays, were able to get through the sunscreen. Next are my data tables. You can see in that I have every single trial and its value for all 3 groups. Then there are the average table, which tells you the average of each group. You can see that there is a difference between none, 0.71, and the 2 sunscreen groups, 0.89 average and then 0.91 average. Because it's a higher number, you can easily see that it is lighter and less sun got to it. And then, of course, the graph, which shows the same information in a different way. Next is my results. After being left in the sun, the sunprint paper without sunscreen had an average 0.71 value. The sunprint paper squares with SPF 30 sunscreen on them had an average value 0.89 value. The sunprint paper squares with SPF 50 on them had an average value of 0.91. My tables show each trial and value. Yes, that's it. I already talked about the graph and the tables and the pictures. My conclusion is my experiment was to find out if no sunscreen, SPF 30 sunscreen, or SPF 50 sunscreen protects the most from the sun. I found the value of each trial. The value is how light or dark a color is. Then I compared the averages of each group, and the results supported my hypothesis. My hypothesis was that the sunprint paper group that I used SPF 50 sunscreen on would be the lightest color. This was what the results showed. The sunprint paper with no sunscreen had an average value of 0.71. The sunprint paper with SPF 30 sunscreen on it had an average value of 0.89. The group that used SPF 50 sunscreen had the highest average with 0.91. The higher the number, the lighter a color is, so SPF 50 sunscreen was the most protective with 0.91 value. There was a clear color difference between the groups. I could easily tell which was the lightest and the darkest. If I were to do this again, I would cut the sunprint paper into larger squares because they were hard to handle being so small. I did shine a light on sunscreen and found it does make a difference, and so does SPF. If I were to continue this or do a project similar, I would want to try a different type of sun protection. Of course, I want to try it on my own skin, but that would be dangerous because of the sun damage. This is my application. The information I gathered in my experiment can be used in real life because it proves that sunscreen really can protect skin from the sun. Now I know for sure what difference sunscreen really makes, and that higher SPF means less UV rays damaging your skin. Here is my abstract, which is a summary of different parts of my experiment. Thank you so much for your time, judges. Have a nice day.